Hi Indam, hi Shudipto, hi Tamali, hi Ankita, hi Pijush, hi Shubhra, hi Arijit, hi Aritra, hi Shayantan. There are lots of names. I am not taking the names. So I am absent due to some work that I have been forced to do. So in the last week I was not able to take any class. So this is a beautiful medium. I have already sent the notes. Please collect it. So today what we'll run, that is a first order control system and how you can analyze the output of any first order control system. So that is the matter. Now in the picture you can see that a first order control system diagram has been given. Input and the transfer function is 1 by 1 plus st, and the output is getting generated. Now I have said in the class what should be the output, that depends on the input itself. If you put an orange in a juice mixer, orange juice will be produced. If the teacher is good, most of the time the result becomes good. So what is the input that actually determines the nature of output? Here we can see the reiteration of that truth. So case 1, what we did, we have given a unit step function. You know unit step function, that means ut equals to 1 for all t greater than equals to 0, and ut equals to 0 for all t less than 0. Now we know the relation ys by us equals to hs. Ys is the Laplace transformation of the output, us is the Laplace transformation of the input, and hs is the Laplace transformation of the transfer function. Why Laplace transform is needed, I have said earlier that we should analyze the whole thing in frequency spectrum. Now ys becomes, by cross multiplication, hs into us equals to 1 by s. We know the Laplace transformation of input, that means ut equals to 1 by s, and hs means 1 by 1 plus st. Now just have implemented some trick to dissolve this function. That means we have written like this, 1 by s minus t by 1 plus st, so that we can dissolve the function just following the mathematics. So we are getting the result 1 by s minus 1 by s plus 1 by t. Here it is written. Is it clear? Now ys equals to 1 by s minus 1 by s plus 1 by t. So what should be the value of yt? Reverse Laplace, inverse Laplace. So 1 by s inverse Laplace means ut, and 1 by s plus 1 by t inverse Laplace means e to the power minus t by t into ut. So taking ut common, we are getting 1 minus e to the power minus small t by capital T. Okay. Now what we will have to analyze, what we have to analyze, that is the error. I have given you proper knowledge. What you are implementing in the examination, that is different issue. So what is the error? What I have delivered, that means input, minus what you are getting, that means the output. This subtraction is very important to find out the error. So input minus output equals to error. Input means ut, because unit step has been applied, and output means ut minus ut into e to the power minus t by t. So these two will be crossed. So we are getting ut into e to the power minus small t by capital T. That is the error. Now we will have to find out the steady state error. That means the error at t tends to infinity. Just put the value t tends to infinity, means t equals to infinity, you know limit, it will produce 0. It will produce 0. So it is a favorable system. The steady state error becomes 0. That means ultimately the output can reach to the level of input. After lots of try, you are delivering the result that I am expecting. Similar fashion. So here we can see the input is like a graph normal, and the output, look, at first output is going, uh, sorry, I have some problem to adjust. How to adjust? Okay, it is getting increased exponentially, but at the level it reaches to the optimum value that is expected. Here we can see ut is input, that means the straight line t ut equals to 1 for all the value t greater than equals to 0. But output initially has a transition. Now gradually it reaches to the value that is expected from it. Okay, so steady state error becomes 0. So it is a favorable system. Now what happens? We will have to describe the same thing when input is ramp. Now you will have to find out the relation between unit step and ramp. If unit step function is ut and ramp function is rt equals to t into ut. Now ys is equal to rs into hs. Rs means the Laplace of ramp input, that means 1 by s square. Hs means 1 by 1 plus st. Again a trick we have did due to dissolving the function, 1 minus st by s square plus 1 into t square, so that it comes in the formula. You can see after dissolving we are getting this value, tut minus capital Tut plus t into e to the power minus t by capital T ut. Now again we will have to find out the error. Error means input minus output. Input means ramp, but we have taken it as TUT. RT equals to TUT. So after taking this and after subtracting it, I am getting capital T into UT minus e to the power minus small t by capital T UT. So that is the figure that I will have to jot down. That is the error. Now if you put capital T tends to infinity in order to find out the steady state error, you will calculate what is happening. A capital T is remaining. This portion will be 0 at t tends to infinity, but there will be a capital T. That means there will be an error even when steady state will be reached. That means at the final level. That is not expected, but it happens. So just look at the graph. The input is like this, ramp input, but the output is not like this. There is bit error, that is capital T. So in this way you will have to evaluate. Now your task is to find out the output and error when impulse function has been applied or impulse input has been applied. It is your task. So thank you for being, and tomorrow I will start another quotient of the chapter, that means second order control system. So just go through and please submit the assignment that I have given, that you will have to find out the output and error response for impulse input through mail. Okay, thank you.